So if you want to hear more of me and what I've said in other classes, you can. And if you're tired of listening to me, you can go to YouTube and find somebody else. Just search for a topic. Has anyone ever actually used YouTube to get like help with math? Yes? Yes. A few of you guys? Yeah. It's insane. There's a lot of shit.
YouTube everything.
On the YouTubes. Huh?
Everybody YouTubes everything.
YouTube everything. Go to YouTube, type in solving quadratic equations. Wade through stuff that you don't like, find somebody you like, go to their channel, see what else they got. You with me? Everybody knows like Khan Academy normally, or there's somebody, OChem tutor or something, I can't remember. Yeah, he does a lot more than just chemistry. They do math related stuff and all this kind of stuff, yeah. So there's a few main channels, but anyway, enough of that. You guys nowadays have so much resources available, it's insane. What got me through grad school was study guides. There was one called Shams you can get from Barnes & Noble or something. It just has explanations, problems, answer key for the problems, like the solutions. You with me? Anyway, so there's a lot of different resources to go to help you through a class. Where did we leave off?
2D.
Thank you. So I think I was bouncing between two papers. Let me do this one. Now, when you first look at this, does it seem like it's linear? What tells you if something's linear? What is the key thing for something to be linear?
Squares.
When the only power on the variable is 1, first power. Do you guys see how somebody might think this is linear, but does anyone notice why it's not? Because the very first thing you're supposed to do is what? Distribute. So what do you get when you start doing that?
X squared.
Keep going.
Minus X.
Good. So you do get that square. And then on the other side, you get what now?
2x.
Okay. So that's the first freaky thing, is this is a quadratic that's kind of hiding, right? So we uncover this dude, we say, we see you. So what does that mean then? This is not linear, therefore, what do I need to make sure it happens? What do I need to have happen for me to keep going?
Equal to 0.
Good, it has to equal 0, yes? So this is what you got to keep in your head. When you see something I'm trying to solve, and it's got a higher power than 1 on one of the variables, you want to get it equal to 0 so you can factor. I need some other way to solve it because I can't get all my x pieces together. They're not like terms. Okay. So how do I make this side 0? What do I do? Subtract 2x and
2.
subtract 2. I like it. So then this becomes 0, and this becomes that. My 2's cancel, right? So this freaks people out, understandably. Is that all right if we do that again? Because people try to, there you go. People try to make the 2 parentheses. That's not the way this is going to work. So something I've sort of not made a big enough deal about, and you're all like, you make a big deal out of everything. The very first thing you should always try is GCF. That is always the first thing you try. Is there something that can come out of both parts? An X. And what's left?
Minus.
Now, this freaks people out. Right? You're all like, every damn step of this freaks me out. What's the interpretation? Why did I make it equal to 0? Because now I have one number times another number is 0. What must be true then? Either this number is 0, and I got an answer. Or this number is 0, right? So either x is 0 or x is 3. Cool. So there's no need to know ahead of time how something's going to work. You just have to know what the next step to do is. And then you re-evaluate. So that's what we're going to see on this next problem. Yeah?
Why isn't that negative 3?
Oh, what makes this 0? Yeah. Or more technically, either the first number is 0, right? So he says either this first number is 0, or the second number is 0. And then you just solve this little dude. And you get x equals 3. pretend like that squiggle is a 3. Okay. Is that alright? So you can always fall back on set each piece equal to 0 and then solve each piece. You don't have to do a lot in your own head. Now this piece. Some of you guys know the answer, the real answer to this, but doesn't this look like it's quadratic? Doesn't this look like it's not linear? If anybody did this problem, you notice something happened. So if I bring this through, what do I get?
4 minus 3x plus x squared.
Good. And then over here, of course, I just double those. If I try to get my x squared stuff together, do you guys see what happens?
They cancel each other out.
Is the leftover now linear?
Yes.
So now, okay. So the whole reason I have to do that weird shit we did on part D is because if it is quadratic, if it's a power other than 1, I have to factor it, get it equal to 0 first. Our x squared piece is canceled. Now I can just solve for x directly. And, well, what does that mean? What do I do now? Now the x scores are gone. I don't have to get it equal to 0. I can just do like we normally would, which is get all the x's on one side, all the numbers on the other, right? So how do I do that? Subtract 4, okay. And then
Subtract it 2.
subtract 2x. And then divide by -5. And you get x is 2. Really squinching this in there.
2 or negative 2? I got negative.
Do you agree with me about, I'm not sure if you did it the same way I just did this?
I did it a little different.
Did you add 3x?
Yes.
And then you added 6.
Yes.
So you should get 10 equals 5x. There should have been no negative sign then. The way I did it, I got 2 negatives, and of course they cancel, yes? You with me?
Yes.
Okay.
I can't see it.
Oh, I'm sorry. Let me get this guy to work there. So the way I did it, I subtracted 4, oh, I'm sorry. Or is it this stuff?
Yeah.
Oh.
It's alright, I can see it.
All right. Not sure what these are doing here. They're like, math isn't hard enough. Let me give you something to look through. So the way that somebody told me to do this was to bring this over, so I got -10 equals -5. So when I divide, the 2 negatives cancel. Now, if instead, if I pick up from this point right here, if instead I add 3x and add 6, then I get positive equals positive. So when I divide, then it's still positive.
This is 2.
Okay, I like it. And don't forget, it's a good idea to check when you have time. It's really nice to have a method to check your answer when you're taking a test. Because the worst thing about a test is you have no safety net. You turn it in, you have no idea, right? Homework you can kind of check and so forth, but test, so it's nice to have kind of a way to actually check to see if your answer makes sense. Okay, I like it. But that's a huge thing that you guys seem to be getting. It's a huge thing for people to realize, when do I have to do that weird shit? When do I have to factor get equal? It's when the power is higher than, is there a different power than 1? On any of your variables, you're going to have to do that. That last problem, it canceled. So I didn't have to do that. Okay. Can somebody tell me, in general, how do I find the y-intercept? If that's all I want is the y-intercept, how would I find it in general?
Set x to 0.
Set x to 0, I love it. This specifically wants me to find the slope and the y-intercept. So instead of doing that, that would be extra work. How could I find both of those at the same time?
Put
Give
it
me-
into y equals m.
There we go. I was going to say, give me the equation of a line. If I solve for y, the slope and the y-intercept just fall into place. This is exceptionally weird. If I just solve an equation for y, the slope and the y-intercept just sort of fall into place. We've talked about why that's true, why those elements are what they are. Later, you guys are going to learn circles. So it's really neat. What do you think is the most important part of a circle? How do I know if it's big or small? It's how big the radius. So if I do the radius, and also how do I know it's here or here is where the center is, correct? If I know the radius and the center of a circle, I can draw it. So the equation, if I put the equation in the right form, the center and the radius fall into place. I can just pick them out. You guys kind of with me? We're not going to suddenly start talking about circles quite yet. But just to show you that these ideas carry further with these geometric shapes. If I have an equation for them, I should see important parts of them show up in the equation. That's kind of insane. Okay. So how do I start solving this thing for y?
Subtract 5x.
Subtract 5x. And I'm going to force it to be in front. Just because I want to put an mx plus b. And then I
Divide by 3.
divide by 3. Can somebody tell me what my slope is? I think I heard somebody back there, negative 5/3. And what's my y-intercept?
0, 4.
0.4. I like it. By the way, I was born in Savannah, so it's interesting. When I go back to Georgia, I got my southern accent coming out, but I don't know why it's happening right now. It just is. Anyway, I'll stop.
Cool. Yeah.
It is. It's just been buried many years outside of.
A lot of good food up here.
Huh?
A lot of good food and a lot of lost memories there.
We like a little tea with our sugar. It's basically the way we do it. Where do I? Just give me a thing of sugar, pour a little tea. It's perfect. What do I plot first? I know these two pieces of information.
The y-intercept.
I always want to point on my line because my slope will get me back to my line. I feel like I'm on a sitcom. So you plot 0, 4, and then what's the slope telling me to do?
You go down 3.
Yeah, down, careful.
So down 5.
Down 5, yeah, 1, 2, 5.
Over 3.
Over 1, 2, 3. Now, does anyone have a way for me to check this besides put it in my graphic calculator?
You put one of your points back in.
Yeah, what point is this?
3, 1.
Careful.
0.
Oh, negative 1.
Yeah. What should happen if I plug a 3 into this equation? Actually, it's even better here. What should happen if I plug a 3 in? What output should I get?
Negative 1.
Negative 1. So if I plug a 3 in, the 3's cancel. What's negative 5 plus 4?
Negative 1.
Kick ass. You can. So again, it's good to know how to check what you just did. Yes? One major thing is the slope is negative. Is this doing what it's supposed to do? Yeah, if this is profit, we're sad. So that's why it's a negative slope. Oh, shit. All right. We're losing money.
May I see how you checked it one more time?
Yeah, so I went down 5 over 3, so I know I ended up at this point, right?
Yes.
If I plug a 3 in, because that's the x, if I plug a 3 in, I should get a negative 1 out, is what that point is claiming, and I did. Therefore, that point is on the line. I'm golden.
What if you want to check, like, what if you plug in y?
Plug in, oh yeah, sure, you can plug a negative 1 in for y and solve for x if you want. You can do it up here. It doesn't matter which one you plug in, the number for the other one should come out. Does that make sense?
Do you divide the x from the 5/3? How do you isolate the x?
It would have been easier to start here and solve for x if you wanted to solve for x. You see what I mean?
Yeah.
Yeah. Or you could multiply by the reciprocal along the way, right? Okay, if you want to. What do we normally consider the input to be? What is normally considered to be the input for a line like this? Which letter is the input, which letter is the output?
Oh, the x is.
X is normally considered input, Y is considered output. That was a complete choice. We could have chosen something different. We just chose to do it that way. It doesn't really matter, to be honest. In fact, in some problems, you're not going to have X or Y. You're going to have like T for time and P for profit or something, right? Okay. Number 4 is freaky. Number 4 is
Not linear.
Yeah, somebody tell me why is this not linear? Yeah. Squared. Okay, so not linear. So what do I expect the graph to look like?
It's an exponential.
Should be some kind of curvy dude. It's not exponential. It's just parabolic. Right? You guys remember x squared looks like that guy? Negative x squared looks like sad? Yes?
I might be wrong, but I think about it because a squared plus b squared. No, that's wrong. That's wrong.
Are you thinking about Pythagorean theorem?
No.
Ax squared plus bx plus c?
Yeah, whatever the parabola one is about how a squared is like the same as x squared. I think I'm thinking about the wrong thing.
You are, I think.
Yeah.
I'm not sure. Okay.
So is I need to look this up.
Look it up and let me know in a
I need
minute.
to look this up.
Somebody remind me, no matter what function I'm looking at, how do I find the y-intercept, no matter what? Make all the other letters 0. So thankfully we only have one other letter. So what happens when I make x 0?
Y is 4.
So the
I
y,
just
you got it, what you got?
ax squared plus bx plus c.
That's okay. So yeah, a parabola will be, a general parabola will be in the form ax squared plus bx plus c. Later you guys will learn like a shortcut to find the turning point. Right. So we'll talk about that in a minute. How do I find the x-intercepts? So y equal to 0. So it'd be 0 equals. Do we have a way to solve this? Yeah, what do I do? Factor it. I love it. This is nice. Multiply before, add to be negative 5. You can do it. What two numbers multiply before and add to be negative 5?
Negative 4,
Negative 4, negative 1. So what are my x-intercepts?
X equals 4, X equals
I love it. So if I plot those, I'll get 0, 4, 4, 0, 1, 0. Now, I was a little evil putting this on here, but can somebody tell me one thing about a parabola? It's interesting because it looks like there is a point where it turns, yes? In fact, do you guys know the name, the official name of that point? Vertex. Vertex. There you go. Perfect. It's a mirror image of itself, correct? So let's see if this makes sense. If I see one point that's on the vertex directly across, it's on the parabola, directly across from another point, isn't the vertex have to be right in the middle? You guys see what I'm saying?
Mm-hmm.
Okay. Do I see 2 points that are directly across from each other that are on this parabola? Right here. So the vertex has to be here somewhere. In terms of what we know, the best I could do right now is just kind of eyeball this. Oh, that's a horrible parabola, Jeff. All right. Good Lord. Hopefully you guys drew better than me. I just had to show you why I'm a math teacher, not an art teacher. But I know the vertex has to be right there in the middle. Does that make sense? Because it's symmetric. That's got to be where the mirror is right between those 2 points. Yes?
Mm-hmm.
Okay. Can we identify the turning point? Not really, but can somebody help me out? Does anyone know what the x is for the turning point, for the vertex? What's this? This is x equal to 1. This is x equal to 4. 2.5. How would I figure out the y part? Plug 2.5 in. I love it. By the way, Abigail, today has turned into a lecture heavy. I'm sorry. You're like, it's fine with me. Okay. All right. So, what I want to talk about now, and I really, it's already 11:20, but this is important. Anytime. They go up?
Yeah.
Oh, yeah.
That's why I raised them. It's also a computer.
Oh, really?
Yeah.
Oh, they do. Oh, I don't know if we're gonna have much time for our little activity, but
I want the best one.
what's up? All right.
On the first row.
Function notations. This is huge. This is a huge part of mathematics. Function notation, what a function is. Today is my movie reference day. Has anybody ever seen the movie Highlander or the TV series Highlander? You know what I'm talking about?
Yeah, cut the head off.
There you go. So it's a beautiful. Today, my two movie references today involve people that are meeting grisly death. But you don't have to have a prerequisite of watching Highlander. But in the movie, there's a guy who's got to kill all these other people, and there can only be one that's the same. So a function is where every input can have only one output. So for every number I plug in, there can be only one output for that. So what the shit does that mean? Well, sort of like, why does this make sense? If I ask a person in here and I say, what size shoe do you have on your left foot? And they give me they say, size 7 and 11. And you're like, do you have 2 shoes on? That question can only have one response, correct? Your response could be, I don't have a shoe on. And I'm like, put your damn shoes on, touch me. You guys kind of, okay. So it kind of makes physical sense. If I throw a ball and they say, where's the ball 3 seconds later? And you say 5 feet up and -2 feet down. Like, what happened to the ball? What kind of ball is that? Holy shit, it's a portable. I love it. You guys kind of with me? I can't have, so a function kind of relates to physical situations where anytime I ask a question, there can only be one answer. You guys kind of with me? Okay, I like it. So what that means is, for example, have you guys seen this notation before?
Yeah.
Do you know how to read it? I know it says right above that how to read it, but do you know how to read this? F of x, kick ass. I can't divide by f. This doesn't say f times x. This is f of x. So what does this function do to a number that I put into it? Squares it, doubles that, and then takes 3 away. So this defines an operation. If I feed it a number, it does that stuff to it. So for example, if I feed this function -2, do you know how to rewrite this so you can figure out what it does? What am I replacing x with?
-2.
-2. So I'm going to write 2 times x squared minus 3. So the most basic interpretation of function notation is it's just substitution. Whatever the hell's in there, you're just putting it in. How do you do that? Let's go to order of operation. Order of operation, oh my gosh. What's order of operations tell you to do first? Got to square first, 11. Good, so you get 2 times 4 minus 3. 5, I love it. So you get 2 times 4 minus 3, 8 minus 3 is 5. So for an input of -2, I get 1 output, 5. Now I wonder if anybody out there is like, how the hell would I put together something where I would get 2 outputs? I'll show you in a bit. Does everyone agree though, whatever number I plug into this, it's only going to give me 1 number back, yes? Mm-hmm. So that's why this is a function. Every number I put in, I only get 1 number back. So here, do this real quick. Finish that up. Figure out each of those. And while you're doing that, I'm going to give out calculators.
It says this is equivalent to blank.
Oh, I'm sorry, yeah. I think I say it somewhere. I say it right here.
Okay.
So this is equivalent to y equals 2x squared minus 3. Basically, we're replacing y with f of x. Does anyone have a calculator with them right now, a graphing calculator? You have one? Anybody else? Okay, I'm going to give everybody a calculator. 1, 2, 3, 4. 4, 5, 6. Sorry.
Need help?
Yes. Just people, thank you, James. Am I recording? Yes. Everybody else need a calculator? There you go.
Oh, I haven't driven, dude. That's what I was like.
Oh!
I forgot.
You're like, you need two. Yes.
Looks like you need to. No, I'm just kidding.
Alright, let me catch up to you. Let's see. 2 times negative 1 squared minus 3. Negative 1 squared is 1 times 2 is 2 minus 3 is negative 1. So while I'm doing this, I'm going to kind of collect these over here. 5, negative 1. Kind of trippy. We put a negative 1 in, we got a negative 1 out. That's all good. When you play a 0 in, that's nice. Can you just eyeball it?
Negative 3.
Yeah, plug a 0 in and just get negative 3. F of 1. Do you guys notice something interesting when I put a negative 1 in? When I squared it, it became 1, right?
Mm-hmm.
So here I'm going to get the exact same output, correct? It'll be 2 times 1 squared minus 3. Is 2 minus 3 is negative 1 still.
So same with the top and this one.
Say again.
Same with the 2 and 2 then, correct?
Beautiful. And why does it make sense? I know this is a parabola. I know at some point it's going to turn around and start repeating outputs, yes?
Yeah.
Okay. So f of 2, of course, will be 5. Does that go against what I said is true about a function? I said a function, every input is supposed to have only one output. And so people sometimes say, no, because look, they both got a 5. No, no, no. Does negative 2 have more than one output? No. So they could all have the exact same frickin' output, just none of them can have more than one output. So let me show you an example of a relation that would not have, that would not be a function. The easiest one I can think of off the top of my head is x equals y squared. If I put 9 in for x, so that'd be 9 equals y squared. What do you square to get 9? Or, so for one input, did it get more than one output? Mm-hmm. Yes! So this would not be a function. It's not a function of x. For a given input of x, I got more than one output for y. That would not be a function. That would mean me saying, where were you at 9 a.m.? I was 3 miles that way, and I was 3 miles the other way. What happened to you this morning? What the shit? Did you have the little twirly dude from Harry Potter you can turn back? I don't know. Okay. Just to kind of show you, because we're making a big deal about the definition of function, I want to show you an example that's not a function. Yeah?
Could you maybe graph what it looks like? Like that,
Mm-hmm.
Could you maybe graph what that would look like?
Sure. What's really neat is, can somebody tell me what y equals x squared looks like? Can you draw it in the air for me? Y equals x squared? You can do it. Yes. Looks like this. Right? 1 squared is 1. Negative 1 squared is 1. So forth. X equals y squared. This might not be terribly, you might see this, why this is true, goes like this. Do you see how that kind of makes sense? I switch the x and y, so it kind of switches. Now it goes around the x-axis instead of around the y-axis. Does that make sense? And here's 3. I'm sorry. Here's 9. Where'd 9 come from? 3 or negative 3?
So y equals x squared would be a function.
Y equals x squared is a function all day. because it only has one output when I plug something in for x. X equals y squared is not a function of x. Visually, why does this make sense? Do you all agree with me that this is an x value right there? It's on the x-axis, so it's a good thing to say. Are there two outputs?
Yeah.
So if I draw a vertical line and it goes through my graph more than once, it's not a function. So if I have this picture, is that a function? Because if I draw a vertical line, at least one vertical line goes through it more than once. That means that one input has more than one output. Does that make sense? Has anyone ever heard of the vertical line test?
Yeah.
The Volt. Okay. The new Chevy Volt. Less vowels. Okay. All right. Today's been, I'm very sorry, today's been very heavy on lecture and stuff, but oh well. I do want to show you the basics of the calculator. Before we do this specifically, I just want to show you the real basics of the calculator. Has anyone never even touched one of these before or just now? Yes, okay. So,
I would always use Desmos, like the
yeah, Desmos, I'm going to show you Desmos because it's good to use, but if we had more computer labs, we would teach more of our classes on Desmos and on Excel, for example. I would teach stats on Excel all day if we had enough computer labs, and we don't. So, one of the most important buttons is the on button. Another good button is the off button. Where's the off button? James.
Yeah, so you click second on first.
Yes, good. So all the little dudes in blue, some of you guys might have a different color. I don't know, depends on how old your calculator is. To access that, you hit the shift key, and the shift key is called second. It's like getting to the second tier. So everything in blue, you hit second on, and that will turn its little dude off.
So turn it off?
Yeah. Now turn it back on.
Now turn it on.
No, turn it on, yeah. Something else really good is if you notice things happening with your screen, if you hit second and the up arrow, it'll brighten it. Second and you hold the down arrow down, it'll darken it. A lot of students don't realize that, and they ask me a question, I take a calculator, I do that, and they're like, what did you do? That's awesome. You know. So second up arrow brightens it, second down arrow darkens it. Yes.
Can I get a because that one didn't work.
What happened to it?
That one didn't work.
Oh no. Is that one you just borrowed from me?
Yeah.
I suck. Alright. Good. Oh yeah. He's dead.
Somehow I was able to access the history section just by clicking the up arrow again too.
Oh yeah, yeah. We'll show you. I'll show you. All right. So everybody's got this screen here with nothing on it, correct? Nope. What happened?
I don't know.
I think it was clear.
Oh yeah, hit clear. You're good. Yeah, everybody hit clear. Clear will clear it out. So everybody's got a nice, fresh, empty screen. Is everybody with me?
Yes.
Okay, I like it. Everybody hit the mode button. See right there, the mode button right next to second? Okay. You get all these kind of options, right? And normally you want basically everything on this side highlighted. This one, radians, degrees, is related to trigonometry, to angles, right? Degrees obviously are angles, radians are something you might not know about yet. So if you're going to take 170, that's going to be huge. You're going to have to know when to switch between the two of them. One main reason I made you come here is how the hell do you get out of this? Anytime you accidentally hit a button and you're in some weird ass menu and like, I don't want to be here, there isn't a button like this for life, I'm sorry, but if you hit second mode, that quits. That gets you back to the nice home screen. Yes? Okay, so if you ever hit something, you're like, oh my god, what is that shit? Just hit second, quit. Get the hell out of it. Okay, so just to show you a couple things. Everybody type this with me. 8 minus 4 divided by 15. Enter. Okay, so let's all make sure we get the same thing. So one thing your calculator understands is order of operations. I'm sure some of you guys have used a scientific calculator before, if not a TI, where you can see the entire thing you're typing. The old school plus minus divided by times, where you type a number and then you hit minus and 7 and the number disappeared. That's shit. You want to be able to see everything you've done. What did the calculator do first?
Divided, right?
Yeah, because it knows order of operations. It knows PEMDAS. Which means if you plug something in wrong, it's going to give you the wrong answer, right? Garbage in, garbage out. Now, what if I then had to square this? Where's your square button? Yeah, right there. Now watch this. This is so cool. I want to square this. It's going to, if I just hit the square button, everybody just hit the square button, bam. It is assuming you want to square the answer you just got. Right? The calculator's like, all right, human, I got you. You're kind of dumb, I got you. I think you meant. So ANS is awesome. It's the last number that showed up on the screen. So if you enter, a good guess would be like 60, because 8 squared is 64, you see what I mean? So let's see how close I got. There, yes.
Why my name is Square? Square.
Say again?
Why my name is Square?
Oh, okay, got you. Your name is, how do you say, Ans?
Yeah.
Yeah, all right. So Ans has a button devoted to him on the calculator. You all are very jealous. Maybe someday you can have a calculator, a button on here. I don't even have a button on here. Whatever. Sorry. Now, I also want to point out that, let's say I do this. Everybody do this with me. You ready? Let's do 9 minus 11 divided by 8 times 4. Let me show you one little thing. You ready? To the, this is your to the button, to the third power. Now let me ask you this. Does anyone have a calculator where you do the to the and it's not up here? Does everybody have the little 3 up here?
Yes.
Okay. Does anyone need me to do that again? Let me do that again just in case. How do I do this without going back? Hold on. I'm going to show you.
I think that's right.
Okay. So let's see. If I want to do 9 minus 11 divided by 8 times 4 to the third power.
Yeah, his calculator does
The little to the symbol?
Yeah, and
Okay.
then the number.
You're good. So the newer calculator writes it the way it would look on paper. The older calculators would have a little caret symbol and then a 3. That's kind of better in a way, because see how I'm stuck? If I wanted to put more shit in, I'd have to hit the over arrow to come down from the exponent. Do you see that? That kind of sucks, because if you forget to do that, oh shit, you're going to get some weird answers. So hit enter, let's see. Now what if I'm like, oh shit, that was supposed to be a 7. Then I could just hit the up arrow, highlight that, enter, and then I can go back and make it a 7. Jeff, you're so smart. It's fine. There we go. So if you ever need to change something, so if I needed to change, maybe that was supposed to be a 5 instead of a 4, I can highlight it, hit enter, and then I can go back and change it. Or you can hit second enter and it brings up the last thing you wrote. If you hit second enter again, it brings up the thing before that. Hit second enter again, it brings up the thing before that. Okay. Someday they'll put a little scroll bar on this, but not yet. Okay. That'll be the TI 100, and then we're almost to Skynet, so there it is. All right. So, man, I'm just talking a lot today, but that's too bad for everybody. What I want you to do, I want to kind of recreate this table in this crazy expensive freaking calculator that should be able to do that shit, yes? Can everybody hit their Y equals button? There's a Y equals button way at the top. Everything on this top row is about graphing. The big old graph button is sort of a giveaway, but if you hit Y equals, I am now able to put a function in. So let's all put that function in that we were using before, the 2x squared minus 3. 2. Put 2 in. My X button is right there. This is my X button. X. Squared. Hit the square button. Bam! Where's the X button? I'll do it again. Right? So 2. My X button is right next to alpha. It's got a bunch of variables. It's like my all-purpose variable button. Right there. X squared minus 3. So it should look just like that. What's up? I'm sorry. What you got?
I think you accidentally did like cosine or something.
Hit y equals. Yeah. Oh, I see. Okay. Man. Oh, good. It's not as bad as I thought. Yeah. You just have to clear it. Just go to it and hit clear. Now put that 2x squared minus 3 in there. Yeah. Is everybody else doing all right? Technology day is always exciting for me because there's about 17 billion different things that could go wrong. Yes?
It's like a pause play on the left of the Y. I don't know if that's going to change anything. But
Pause play.
I don't know if that's gonna do that.
Oh, that's weird. Oh, yes. Let's find out. Tell me if it's something different than me. There's 17 billion things that could go wrong. There's 17 billion programs that people can download and make the calculator do different things. Believe it or not, I don't know all of them. So, what I want you to hit right now is hit second graph. Let me know what you see. Do you see something like what I have?
Yes.
Let me know if you don't see what I have. Second graph that takes you to table, right? Does everybody see what I see?
I see something different.
Mm-hmm.
I see it.
You hit. All right, you hit. Don't worry. You're fine.
Okay.
I'll show you in a minute. You got it? Everybody good? Yes?
This is what yeah.
Oh, you're fine. I'll show you. I'll show you. You're ahead of us.
Did you put in the correct formula? His looks different.
Let me see. What you got? You're fine. I'll show you. You're ahead of us.
Did you do that?
Now everybody hit second window. See above window it says table set? For me, my table started at 0 and it went by ones.
Mine says it starts at 3.6.
You're fine. Don't worry. You're fine. Somebody else changed it. So I'm just showing you what mine says. Why did my table look the way it did? Because it says 0 and it goes by ones. That's why I went 0, 1, 2 on my X's. Everybody with me? If those of you had different stuff, I think most of you guys, does it say ask here instead?
Yeah.
Oh. Hit second window to go to table set. See how it says table set? Now I can set up my table. This is the standard that the table normally starts at. So just to show you, if I make this 8 and I make this 2 and I make this auto, is everybody with me? Can everybody make sure yours looks exactly like mine? 8, 2, auto, auto. Hold on. Now go back to table. Second graph to go to table. Do you see now how the inputs start at 8? How much do they go up by? 2. Okay, good. So you can control it that way. Here's the ultimate best way to control shit. Or at least, on the calculator. Don't get too excited. Second window. You guys ever heard of independent variable versus dependent variable? If I have y equals 2x, doesn't y depend on what x is? Because it's double whatever x. So x is independent, y is dependent. So if I make my independent variable, if I tell the calculator, don't do shit, you ask me, change it to ask. And I'm almost certain some of you guys had weird stuff you had to ask already. Change it to ask. Now go back to your table and look what I've done. Took away all your information. No. So you got a table? Yeah. Does everybody have a blank table now? Let me do it again. hit second window to go to set, change this independent to ask, now hit second graph to get back to table. So now if I put in there -2, it'll do what I ask it to. So I can construct manually an XY table. -1, 0, 1, 2. Are those the answers we got?
How do you clear
Yeah.
how do you clear out a table that's already been filled?
I think you just, let me see if I remember.
You hit the delete button.
Here's a nice way to do it. You ready? I'm going to do it this way. I'm going to make this auto. And then I'm going to make it ask.
Oh, okay.
Kind of makes it clear. I think you can delete each one. That's just quicker to do.
Alright, mine goofed up when I went back to the table. So these are my settings.
Yep.
And then I went back to second table. And then six.
Oh, yeah, yeah. Okay. Because you had stuff in there before, right?
Yeah, I think so.
Yeah, let me do this. So just kind of reset it.
Okay.
So now, if you needed to know what it was at 1.478, you can tell exactly what it was at 1.478. Not exactly, really. It only goes 3 decimal places, which is kind of bad, but you know, it works for whole numbers pretty well. You guys all with me? So a big part of algebra was constructing XY tables. Do you guys remember this? To graph functions and such? Okay. All right. So for each one of these, for example, this one. Let's do this one, and then I'll do one of these graph ones. Yeah, this graph one at the bottom. Can you guys do this without a calculator? G of 0.
Right?
Yeah. If you put a 0 in for x, the only thing left alive is 1. What about -4? Can you guys do that without a calculator? What's -4 squared? 16 minus 2 times -4. What's -2 times -4?
Oh, that's 8. Negative.
Positive 8. So I should get
9.
16 plus 8 plus 1. Do you guys want to do this one? If I force you to, you should be able to, yes? Yes. The first part will be 1/2 squared is 1/4, right? This is nowhere near as bad as you think, to be honest. 1/2 squared minus 2 times 1/2 plus 1. Is that cool? Just throw it in. The first step to any function question is just throw the value in. 1/2 squared is 1/4, yes?
Mm-hmm.
What happens to the 2's here?
They
Cancel out.
So we get -1 plus 1.
Cancel out.
So the answer is 1/4. Yeah, so you were ahead of me. Okay, gotcha. I thought that might be happening, but I had to do it. All right, so let's double check this. Can you guys go ahead and put this function into the calculator? Put that function in. And then try to construct a table. You can just overwrite shit in the table. You don't have to clear it. You can just overwrite it. Put the function in, and then check those 3 answers that we got.
Should I graph?
Not yet.
Oh no, I was trying to figure out how you got to that.
Oh, y equals. To get to here? Yeah.
Okay.
So again. X squared minus 2x plus 1? Yeah. But don't put the numbers in. Yeah, yeah. Okay.
I see what it is.
I want to change the order.
Change the order. Oh, go from auto to ask? Go to table set. Yeah, go to ask, and hit enter. Hit enter. That activates that part, yeah. don't grab it. Yeah.
Oh, okay.
Don't grab it. Yeah. Yeah, you got one that somebody was using for statistics. So if I go to my table, I got stuff in here already, but I can just override it. 0, -4, 1/2. Are those the same answers we got? We got 1. We got 25. 1/4 is of course 0.25, right?
Yeah.
1/4, 25 cents. Love it. Kick ass. How about -2/3? Well, I could just put in there. By the way, do you guys see 2 minus signs? 2 negative signs?
Yeah.
One is minus, and the other one is negative. They are hardwired into the calculator differently. If you use them at the wrong time, it'll either give you the wrong answer, or it will give you a syntax error. So right now, I want to use -2/3. And it tells me the answer is 2.7777. Maybe.
How'd
They
you
don't
get the
want us to-
question?
Oh, I just plugged in. All I did was I put -2 divided by 3. Because that's all a fraction is, right? Yeah.
So we don't have to plug in the whole function?
I already did.
Or the whole,
The function is sitting right there.
yeah, that's fine.
Right in my y
I'm still
equals.
stuck on that.
Oh, shit.
Yeah, I'm-
So if I feed the calculator a function, it'll then reference it to do this work.
Right.
Alright, watch this. Everybody come back to the y equals page. And everybody's got this in there, right? Hit the down arrow and let's put in here x minus 5.
I'm okay.
You're good? Is everybody with me? So now you have 2 functions showing up, yes? Go back to your table. Oh, everybody with me?
Forgot how you get back to that page from the table.
Y equals. Just you hit y equals, yeah.
Okay, oh, there we go.
Yeah.
Wow.
So now if you hit second table, do you see how now it's got 2 outputs?
So it's,
Now mine is in color. Yours depends on how old your calculator is.
Yeah.
it's got all kinds of numbers. Weird.
So these are the outputs for the first function, and these are the outputs for the second function.
I don't know.
Well, do you have these functions?
It's because he plugged some in.
Oh, I'm sorry. Yeah, you might have.
Squared.
I plugged some inputs in. Yeah.
Yeah.
I plugged these
Like
inputs in.
plug
X
these.
squared.
X squared minus 2x plus 1.
I'll catch up.
That's right. We're basically almost done. All right. Obviously, that's not a lot on the calculator. What I put up in our Canvas shell is I put 2 graphing calculator worksheets or handouts. One of them I used to call the Graphing Calculator Bible, but it's just a quick reference for algebra-based classes. I have one for stats classes, so I know at least one of you guys is going to take stats. I could share that with you. It kind of like goes over all the operations you need in your stats class. Another handout is also related to Graphing Calculator. Another teacher made it, but I thought I'd just put it up there just for another reference in case mine sucks. You want to look at the other one. So don't forget that Canvas shell. I'm going to keep adding stuff to it. I put our handouts up into it. Let me just bring it up. Jeez, I keep talking about it. Oh, that's my 176. So when you log into Canvas, you should have a list of all your classes. If you click on Math 95, you'll get here. If you go to discussions, this is where I posted the question about what the hell do you wish I would talk about. You could create your own discussions too. So if you want to add a discussion, you should be able to put it, and then people can interact with you. You could try to set up study groups or whatever if you want to. You could just never make one if you don't want to. It's there if you want it. Under modules, I've got good things to know and have. And one of them is a TI guide. That's the one I made, and the other one's TI Calculator Basics. That's one of my colleagues made. So I thought I'd just throw them both up there in case you like one better than the other one. I've also got the student services and so forth. One thing I'm going to add over to this side is a link to all my videos. Like I told you, I've recorded every lecture since 2011. It's insane. So I like to go back to 2011 and look at young Jeff up there and go, what has happened to this guy? Also, it helps me because I'm like, did I say there was a quiz? So then I look at the video. Oh, yeah, I did. So even if none of my students ever watched them, I'm like, it helps me. I'm like, what did I say? Oh, yeah, that's right. Okay. Let me see. Oh, last thing. And then we'll go eat some lunch. And by the way, just to let you know, tomorrow we're going to have a very special guest at lunch. The president of the college is supposed to be stopping by just to say, hey. So that'd be nice. You should probably hang out for lunch and say, hey, get on a good side now. That's it. No, unfortunately. Yeah, he's stopping here to have a very specific rally for Kamala with us. Now look at what I'm asking you to do. I'm asking you to figure out what g of 2 is. Did I tell you what g of x is? Did I give you a function? I did better than that. I gave you all the freaking answers. You don't have to calculate anything. So when you plug a number in and you get a number out, isn't that a point? You can then plot the point. So if I ask you, what is g of 2, what do you have to find? Somebody's already done all the work. For an input of 2, what was the output?
-7.
Yeah, for an input of 2, the output must have been -7 because that's where they put the point. Does that make sense?
Mm-hmm.
If I plug a number in, that's x. If I get a number out, that's y. I can then plot that point. So they didn't give me the function, they gave me better. They gave me all the answers. And you're like, do that whenever you want to. So g of 2 must be -7 because that's where they put the point. Do you guys get that?
Mm-hmm.
Okay. So the rest of these work the same way. What's g of 6?
5.
5, right? Because 6, an input of 6 has an output of 5. G of 4?
-3.
-3. So once you get the idea, these are pretty straightforward, yes? But it's really trippy when the students see this for the first time. They always say the same thing. I'm like, what do I plug this into? You don't have to. Somebody already did. It's awesome. Yes?
What's g of -5? Because it looks like it's in the middle.
Let's see. G of -5. Oh, here. Yeah. This is where you have to estimate. What would you guys think? It's in the middle, so what would you say? In the middle of what? 4 and 5. Yeah, this is not really nice to people that can't see too well. G of -5 looks to be right between 4 and 5, so what would that be? 4.5. I like it. That's the best we can do. So since we're doing this by sight, it's okay if we're a little wrong. We just do what it looks like. I like it. So you'll see problems just like this in your classes if you're taking pre-calculus. Okay. One more thing I want to show you, then I'll go see if the lunch is ready. It might not quite be ready yet. Somebody referenced this earlier. Have you guys ever seen this?
Yes.
Yeah.
If you've never seen this, I want you to know this exists. So this is called Desmos. You can just go type in Desmos into Google and it'll take you here. You can then type in y equals x squared minus 2x plus 1, and it will graph it. If you click the picture, it'll give you the y-intercept, see there? The x-intercept. You with me? A little bit? So then you can plug in all kinds of weird stuff. You can put x to the 3rd power minus 4x to the 2nd power plus 5x minus 2. And you get this little, and you see how it gives you like the lowest point here? And it gives you this intercept, it gives you this intercept. It's kind of silly. It's a lot more powerful than the graphic calculator, but why do we use these? Because we don't have enough of these. We don't have enough computer labs. So, yes?
Wait, so what stretches and like...
Oh, yeah, that gets later. So, like, if I put a 2 out here, it's going to go up faster. So the number in front is kind of like the slope. If I put a negative out front, it flips over, right? So you're talking about what's called transformations.
yes.
So very quickly, since you asked. Y equals x squared. We know what that looks like. What if I put in here y equals x squared? What if I put minus 2? What do you think is going to happen to the picture if I put minus 2?
Move down. Shift to the left.
If I put -2 right here, it's going to be that picture, but all the outputs are going to be 2 smaller than they were. So the whole picture is going to go down. So a good question would be, how the shit then, Jeff? Or even a better question would be, excuse me, sir, how would you make it move left and right? Up and down is Y, correct? Do you see how I can put that -2, I can put it with the Y? Left and right is, of course, X. So if I wanted to move left or right, I'd have to put the number inside with the X, because X is left and right. Are you with me? So what if I were to put up here, this is such a weird way to do it, but Y equals X minus 2 squared. What do you think it would do?
Go to the left.
Wait, no, right. Go to the right. Wait, no, that's the wrong rule.
So here's, listen guys, you ready? When you put a number in, give me a number. 3. If you put a number 3 in there, what's the first thing that happens to it? When you put a 3 in, what's the first thing you do to calculate this?
You subtract the 2.
I subtract 2. So to get the same outputs I used to get, doesn't every input have to be 2 bigger than it used to be? Let's say you're going to a club and it costs $10 cover charge. You with me? And there's this one really very specific mugger who stands in front, and he always steals exactly $2 from everybody, and nobody does anything about it. And you're like, what the shit? So if it costs $10 to get in, and you know this guy's going to steal 2, how much money do you bring? At least $12, and then you hope somebody's going to buy you drinks. You with me? So if you bring $12, can you get in? Yes. Doesn't your input have to be 2 bigger than it used to be? If he wasn't there, could you just bring $10 and get in? Okay, so this is like the mugger taking $2 away from each of us. So all of our inputs have to be 2 bigger. It's going to move the red shift. It's going to shift the red to that way. So let's see what happens. Let's see if Jeff understands what the hell he's doing. Hey, look at that. When you plug a 2 in, what do you get? What do you get when you plug a 2 in? 0. What did I used to plug in to get 0? 0. So now everything has to be 2 bigger than it used to be to overcome the fact that some jackass has taken 2 away from me. That's one of the weirdest things to get down about transformations is there's a -2. Why doesn't it go back? Because we have to overcome that -2. We actually have to go the other way. Everything's got to be bigger.
What if it's +2? Does it go?
Then it would go back. So if I change this to +2, and look what I can do. You guys see that? The green now is back. One nifty thing about Desmos is if I put a letter in there, I can add a slider, and then you can just see this thing. Wee-haw, wee-haw. So negative is going to go over, and positive is going to go back. Yay! And then I can even do this shit. Plus B. I can add another slider. I can slide B. I can slide A. I can do all kinds of weird shit. Wee. Okay, sorry. So Desmos is really powerful. I like it, and we would use it more if we could. Lunch should almost definitely be ready. So let me go make sure, and then I'll tell you guys to come over.